question 3. So we're told that the P coordinate is 7, 8 and the Q coordinate is 10, 13, and we're being asked to find the length PQ. So this is purely Pythagoras. So the length of the base from 7 to 10 is 3. The height is from 8 to 13, which is 5. So just Pythagoras, PQ squared equals 3 squared plus 5 squared, so PQ equals the square root of 34. They ask for an exact value, so you've got to give it as insert format. Now for part B, write down the equation for C. That's the equation of the circle, so that's x minus the x component of the centre, all squared, plus y minus the y component of the centre of the circle, all squared. Now that equals the radius squared. Well, we've just worked out that the radius squared is 34. The radius itself is root 34, so hence why the right hand side is 34. Now for part C, we've got to work out the equation of this line, so we're going to be using the big formula y minus y1 equals mx minus x1. We need to know two things. We need to know a point on the line. Well, we know Q, so x1 is 10, y1 is 13. x1 is 10, y1 is 13. And we also need to know the gradient of the line L. Now the gradient of PQ, we can go back to this original triangle. That's the y step over the x step, that's 5 over 3. So the gradient of the tangent, in other words the gradient of the line L, we flip this over, change the sign, so that's minus 3 over 5, giving us this. Now I think the easiest thing to do here, particularly when we've got to give it in this integer format, is to undo this dividing by 5 at this point. So I've chosen to multiply through by 5, so y times 5 and minus 13 times 5 is 5y minus 65. So that gets rid of the denominator, just leaving us with minus 3 to be multiplied by x and the minus 10. Minus 3 times x is minus 3x, minus 3 times minus 10 is plus 30. Then I've taken it all over to the left hand side by adding 3x and taking away 30 to give us 3x plus 5y minus 95 equaling 0.